So in this demonstration, we are going to observe magnesium. And this is a strip of magnesium. It is a metal and it looks like it. You can tell. And we are going to combine this with oxygen. Now, technically there's plenty of oxygen in the air for it to combine with, but it not really happening right now. We need to give it a little bit of energy to get it moving and really reacting. So I am going to heat it up a little bit in order to give our reaction a little bit more energy. But what I wanted to show you real quick was that using a normal candle is not quite enough energy to get it going. So even though that is getting it hot and going, it has a certain temperature it has to be at before we're going to be able to get them to combine. So a normal candle won't cut it. What I've got over here is a Bunsen burner, which is attached through this gas line to basically some methane gas, a lot like the propane you connect your grill to, and it produces enough energy to get this going. So we have that and now, hopefully you don't have a bright spot in your vision like I do. You can see what was left over. I'm going to drop it on this second watch glass here so that you can see it and maybe observe it compared to its original form. And now I'm going to do the same thing again, but this time I'm going to do it with the lights off. And there we go. Give you guys a closer look of those leftovers. You can see a little bit of that unburned magnesium. And oh yeah, that's much better resolution. Picture of what's left over afterwards.
Okay, so in this reaction, we started with those magnesium strips, and remember, even when we put something simple like an element in a chemical equation, we have to remember to check our diatomics. So magnesium is not in our Brinkelhof or I bring clay for our new house, so it does not need a 2, it just gets to be written as Mg. And because we're trying to combine that with oxygen, we are going to do a plus O, and oxygen is a diatomic, so we have to write out oxygen as O2. So don't get kind of lax when you're writing out these equations, and be focused on balancing things. And even when you're writing out something as simple as a single element, you need to be checking something, and in this case it's diatomics. Now, these are combining together, so these are going to form magnesium oxide, which, lucky for us, magnesium is a +2 charge, and oxygen is a -2 charge, so those cancel each other out, and we just need one of each for that final formula. We could cross-drop reduce and bring the 2 over and this 2 over, but after we've crossed the 2's and dropped the plus and minus signs, we'd still have to be reducing, which means that both of those 2's would turn into 1's, which would leave us just with MgO anyway. So either way we look at it, we're going to end up with MgO as our product. Now just needs balancing.